So I begin with the following problem. Suppose you are given the function x plus 2 cube, right? And then maybe put a square there. Find the derivative y with respect to x. Now what does that mean? We have two variables, x and y. Y depends on x. Seems pretty complicated form. But I know x squared plus 2 cubed is a polynomial. I already know how to find the derivative of polynomial. Just differentiate each term, right? Using the power rule. But this is not in the general form of a polynomial. Well, then you have to search for the formulas. How can I write this like a sum of the many several power functions? Yes, we do have the formula, right? You multiply this out, and you get x squared and the cube plus 3 x squared and square times 2 and plus 3 x squared 2 square and 2 cube. Okay, then you simplify, you will get x to the 6 plus 6x to the 4th power and plus 12x squared plus 8. So this is a polynomial, indeed a polynomial. Then it's easy to find the derivative. Yeah, this is a notation. dy dx is the derivative of y with respect to x. Okay, the quantity y depends on x by this formula. So what you have to do is just differentiate each term. So you know how to get that, right? 6 times 4, x cubed, and the 12 times 2, x, and plus 0. Right? So the plus 0, then you simplify a little bit, and you solve the problem. All right. We can do that because we have x squared plus 2. We know the formula for a plus b cubed. If I change 3 to 30 or 100, it's impossible to write down 100 terms. Then you find the derivative. Right? So what happens if I change the problem to 30, right? Do we have a formula to expand it? Yes, we do have the formula, but we don't use that very often. It's pretty complicated. The formula, yeah, I don't think everybody knows this formula for this. A plus b to the nth power. And can you write down all the terms when they multiply out? Yeah, multiply them out. Okay. So how do you solve this problem? The idea is, here's the idea. The relationship between y and x is complicated, right? Suppose someday you create a conflict. At the very beginning, you only work with a process, simple. Okay, next month, next year, doing hire 10 people, and then hire 100 people, right? And you cannot just directly talk to each employee, right? So it's then you have to, make some, give some titles to some people called managers, right? Right. So there's some, it's more people were added in the level because if the company is expanding. Okay. So you basically cannot directly talk to the employer when the company is getting big and big. If you hire like 10,000 people, it's impossible to do that. Okay. Then we have to introduce some variable between y and x. We can find, the meaning of the derivative is the rate of change of the quantity with respect to another quantity. But the dependency of y on x is very complicated. It's harder to figure out the rate of change, okay, of the y with respect to x. So we're going to introduce a minimum. Okay? So I'm going to express y as like w to 30. And the w is going to be x squared plus 2. See, y depends on w depends on x. And the dependency is quite simple, each of the dependencies. Okay? And then will be, we were saying we're beginning easier to find the derivative. So what I'm going to do here is this is called a chain rule. The derivative of y with respect to x is going to be the derivative of y with respect to w, and the derivative of w with respect to x. Okay, you can introduce more variables in the middle between y and x if the dependencies of y on x is getting more and more complicated. Okay, so you probably have to introduce more variables. Okay, manager, general manager, the middle manager. That's get more. Okay. So you see, then this is called a chain rule, right? Okay. So then the dy over dx is just y is w 30, and the w is x squared plus 2. Okay. So now using the formula, it's a 30w 29, and here is going to be just 2x because the derivative of x squared is 2x. Right, so we're almost there. Then what is w? W is x squared. So 30 times 2 is 60, x. Then x squared plus 2 to the 29th. That's good. So that's it. This is the whole idea about chain rule for today's section. All right. All right. We introduce a variable w between y and x. And you stay able to figure out the dependent, the rate of change of y with respect to x. Okay. All right, so the next problem, y equals square root of 1 minus x squared. Find the derivative of y with respect to x. It will be the same idea. So y equals square root of 1 minus x squared. Okay, so 1 minus x squared. This is the dependence is pretty complicated here, right? So it's very natural to introduce another variable. So y equals square root of w, and w equals 1 minus x squared. Okay, right? Or you can say where w is equal to 1 minus x squared. That's the first step. And w is also, this can be also written in the form as a power function, right? Then dy over dx, it's easy to memorize a chain rule. You think about the derivative as a quotient, two differentials. Then dw cancels out, you get dy over dx, right? But dy over dx is the derivative of y with respect to w. So let's see, and this is the w to the 1/2, and d. Okay. All right, so now I'm going to 1/2 minus 1, yeah. And this is negative 2x, and 2 cancel out. I get a negative x, and w is going to be 1 minus x squared to the negative 1/2. Now, if your original question is in traditional notation, radical, so you can also express it in that form. Okay, and both are correct. All right. Let's do next problem. Find the derivative of yeah, y equals cosine, this, right? Y equals cosine x, cosine square, for example, right? And then we want to find out the derivative of cosine. I'm going to put cosine x. Okay. Find the derivative y with respect to x. Well, we know that the derivative y. What we know is the derivative of cosine theta with respect to theta is going to be negative sine theta, right? So make sure theta correspond. So this is a derivative of cosine theta with respect to theta. So it's the same theta here. That's why it's going to be negative sine theta. But here, you can write W and then you can say cosine theta. But theta is going to be cosine x. Okay. So dy over dx, that's a derivative of cosine theta with respect to x. You cannot just say it equals negative sine theta. So you have to write. Okay. Then the derivative of y is a cosine theta, and this is a derivative of theta. Theta is going to be cosine x. Then you get negative sine theta and then negative sine x. Okay? What is theta? Theta is cosine x. So you will get negative positive sine cosine x. Then sine x. So this will be the answer. All right, let's do the next problem. Y equals x over 1 plus x cubed. Find the dy or dx. All right, so now it's pretty complicated, right? It's x over 1 plus x. At least we can introduce one variable w, which is x over 1 plus x. I cannot express w in another form. Just this is probably the simplest form. Yeah, x over 1 plus x. Okay. Then I have to find the so this will be dy and dw and then dw or dx. The first part is easy, right? So let's do that. This is going to be the derivative of y, and that's a 3w squared, okay? And you can change it back to the function in terms of x. But dw of dx, the derivative of w with respect to x, you have to use a chain rule, no quotient rule, yeah. So there's no easy way to do that. It's 1 plus x squared, and then the derivative 1 times 1 plus x minus x times the derivative denominator is also 1. Right? After you simplify it, you will get what do you get? So you will get 1 over Okay. Then you put everything back to the above identity. Okay. So that would be 3w squared, and that would be 1 over 1 plus x squared. W is going to be x over 1 plus x, and that's cube, right? It's a square now. W is x over. Okay, so you can combine them together. You will get 3x squared, 1 plus x squared to the fourth power. Okay. Yeah. So that is answer. All right, so the next one, we are going to do 1 plus cosine x squared and the square. Okay. Yeah, you can put cube here. Okay. Find the root of the y with respect to x. All right, so now, pretty complicated, right? Y equals something cubed. That is going to 1 plus cosine and square. The dependency is pretty complicated, but you can figure it out by introduce some variables between x and y. Okay? Then you let, first of all, it looks like a power function for w. Okay? Then w is going to be 1 plus cosine x squared. But I don't like x squared there, so I'm going to get the 1 plus cosine theta. How about like that? Then theta is going to be x squared. All right. So the relationship between theta and x is simple. Okay, theta equals x squared. The relationship between w and theta is also 1 plus theta. Okay. So we introduce two quantities between y and x. So you have two quantities here. Just because the dependence is very complicated, so we introduce two more, then we can do the step by step to figure out the dependence of y on x. So y equals w cube, w equals 1 plus cosine theta, theta equals x squared. So when you differentiate y with respect to x, you have to differentiate y with respect to w, differentiate w with respect to theta, and differentiate theta with respect to x. Okay, that's called a chain rule because you can make this one very long. If you introduce 10 quantities between x and y, then you have 10 pieces. Okay. Yeah. You know, even like a university, we have the president of the university, and we have the dean of each school, and the school, and the chair of each department, right? And have faculty members. So we introduce between the president and the faculty, we have a dean and the chair. So we have two variables, two quantities. Right? All right. So now let's write down. Yeah. So this is our replace y by x w cubed. Then here you replace w by 1 plus cosine theta. Then you replace theta by x squared. Then you see that's 3w squared. That would be negative sine theta. That would be 2x. Okay. You multiply them out, it's going to be negative 6w squared sine theta and x. So I'm going to replace everything. So W is going to be 1 plus cosine theta and then cosine squared. And sine theta is going to be x sine x squared, then x. So that's it. So this is a derivative of y with respect to x. Okay. Anyway, so here's the notation, right? When we say dy dx, this is actually is derivative y with respect to x. That's our notation. Okay, dy with dx means derivative y with respect to dx. Okay, so actually, this channel is the same as, this is the same as the derivative y with respect to x is going to be the derivative y with respect to w, and the derivative of w with respect to x. But if you write in this form, it's harder to memorize, confused. But that's the reason we express, we express by this one by dy over dx. Then it looks like the quotient of two quantities. And then the channel is become very natural because okay, it's easy to memorize because dw cancel out. I get dy over dx back, right? But here you cannot say dw dx, dw cancel out, right? So dw here on the left hand side it's a different meaning. So so this is these two are essentially the same, just notation. Okay. So my question is, what is f? I put f of y. Okay, we are talking about the derivative y, f of y with respect to x. But this is so the variable y, it's inside. It's not x. Okay. Actually, y depends on x, but it's hidden. The dependency is hidden. Y depends on x. So how can I express this? So you can let z to be f of y. How about like that, right? Then dd f of y is just the dz dx, right? Then you use a general, it's going to be dz of dy and dy dx. Clear, right? All right. What is a dz over dy? Dz, that's a derivative of z with respect to y. And this part, we know that. Okay? So this can be also written in f prime y dy dx. Okay, got it? So now we have the following. It's going to be f prime y dy of dx. In other words, if you see a function like in this form, you differentiate y first with respect to the y variable. Then you have to differentiate what's inside. Okay. So this is it is nice formula. Okay. So let's do this. The derivative of this 1 plus x cubed and to the fourth power, right? Think about this. This is just the y variable, right? You put a y to the fourth power. Okay, so you can solve the problem directly. And f of y is y to the fourth power. So you differentiate. You differentiate this. It's 4y cubed, right? Then you have to differentiate what's inside. Okay, you don't need even mention the intermediate variable. You can do it directly. Okay. Yeah, here f of y is going to be y to the fourth power. Okay, but you're trying to find the derivative of this with respect to x, in other words, with respect to y. Okay, this is a f power y. Okay, this is a dy of dx. Okay, so it's going to be 4 plus x cubed and 3x squared. So that's but you can get this using using chain rule. Yeah, actually we are using the chain rule here. Okay, so for example, find the derivative of x. Okay, yeah. What does that mean? You're going to find the derivative of this complicated function. To simplify your notation, you can simply write like y to the negative 1/3, and here y equals x squared minus 1. You can write directly like this. Okay, but this is a derivative with respect to x, and the y is going to be x squared minus 1. Right? Then you have to differentiate this function with respect to y first. But don't forget, you have to differentiate y with respect to x. So that is going to be negative 1/3 y to the 4/3, and dy of dx is going to be x squared minus 1, right? So let's write down the details. Y is going to be x squared minus 1 to the negative 4/3, and here's 2x, and you solve the problem. Okay. What I want to say that you don't need to introduce the variable y here. You can do this directly as long as you still use the chain rule in some way. Somehow it's going to be x squared minus 1 to the negative 1/3, right? Then you view this like a power function. So it's 1/3 x squared minus 1 to the 1/3 minus 1. But don't forget to differentiate the inside function. Yeah, if you can do faster, that is how to do it. Okay, you don't even mention the y variable. Okay, and that is going to be 4/3. That's 2x. But you can do that only after you are familiar with the chain rule. Okay, so let's do the next problem. F of x equals x plus 1 of x to the fifth. Find f prime x. Okay, there's a how do you do this, right? So you can introduce many variables that you want. Okay, you can say y to be f of x, right? Okay, then we actually want to find dy over dx, right? F prime x equals dy over dx. And that quantity was respect to x. how do you, yeah. So then you have to use a channel, right? The channel y equals here's w to the fifth, and w is going to be x plus 1 of x, which is x plus x to the negative 1. Okay. So now, dy of dx, dy of dw, and the dw of dx. Okay, so that will be w to the fifth. That will be x plus x to the negative 1. Right. So 5w to the fourth power, and here's 1 minus x to the negative 2. W is going to be x plus x to the negative to the fourth power. Okay, that would be the answer. Okay, so this is a derivative of y with respect to x that gives you f prime x. Now, can I try to do it directly? If I want to find the derivative of x plus x 1/2 to the fifth, right? You can do it directly. Okay, so you can write in this following form if you want. Okay, you view this as w to the fifth, where w is going to be x plus 1 of x. Okay, but this is a derivative with you let w to denote x plus 1 of x. Okay, replace x with x by 1 of x. All right, so then it's going to be the derivative power function with respect to x, not with respect to w. But you can express in this form, okay, as a channel. This is a channel. All right, so that is going to be 5 w to the fourth power. dw dx is 1 plus 1 minus x to the negative. So then you get the same answer. Okay, so there are other notations if it's composite of two functions. Okay, the derivative of x, f of, right? All right, so the derivative of this is going to be f prime g of x and then g prime. This is a channel in another form. You can prove that directly. Use a channel. Okay. So let's look at the function sine square x. The derivative of this function with respect to x. Right. So it's actually composite of two functions, right? Composite of two functions. And f here is sine. G of x is f is sine, right? G of x is going to be square x. Okay. So f prime becomes cosine. So that's going to be sine prime. Right? And then you just differentiate with respect to x. So that would be cosine square x. And that is going to be 1 over 2 square. 1 over 2 times square x. Now, if you don't want to use this, just use a variable, right? How to do that? Well, this is actually pretty complicated. So y, you have to say y equals square x, and that's to be sine w, and w is going to be square x. Okay? So what they have to find out, you have to find out the derivative of y with respect to x, right? And that is derivative of y with respect to w, and w with respect to x. Okay, so now it's y is going to be sine w, and dw is going to be square x. All right, so the derivative of sine w with respect to w is going to be cosine w. And this is a 1 over 2 times square x. Then replace w by square root x. Okay, wait then. All right, sometimes it is product to functions. One of them is a composite of two functions, like h of v times third root of 1 plus v squared. Right. How to do this problem? Use the first step, find the derivative. The first, you can use a product, right? So that's the product of two functions. So the derivative is going to be v prime okay. So the derivative of v is going to be 1, right? The third root 1 plus v squared plus v. There's a third root 1 plus v squared. You have to use a chain rule, right, to solve this problem. So this is actually, you can simplify it. Let's say this is a w, right? The third root 1 plus v squared with respect to v. So you can, how do you differentiate that quickly? That is a derivative of v, right? So I can write it in this form. Okay, so when you differentiate y with respect to v, right, you get, you see, first of all, different. This is a 1/3 y to the 1/3 minus 1. Then don't forget to differentiate y with respect to v, okay, which is 2v. Okay. So now, that's 2v. Okay. Yeah, it's pretty complicated. Then you have a negative 2 over a positive 2 over v squared. And what is y is 1 plus x, 1 plus v squared. Okay, so that's it. That's it. All right, let me ask you to do the following problem. Find the derivative squared tradition square. So we don't need the 2 there. It's a square for 1 plus v to the first power. Now please do this problem. Okay. Yeah, just a v, not the negative y. It's my notation. It's a v to the fourth power. Always right. Okay, right. All right, you can do it directly. Okay, this is a derivative. 1 plus v to the fourth power and to the 1 half, right? So this is it's kind of a power function. But so first of all, it's going to be 1 half 1 plus v to the fourth power, 1 half minus 1. Then you have to differentiate what's inside. Right? So it's going to be 1 half 1 plus v to the fourth power to the negative 1 half. But when you differentiate the v to the fourth power with respect to x, you have to do this. Right? Don't forget the dVOT. So the final answer will be okay. So this term, be careful, pay attention to the variable you're work on, right? This is a derivative with respect to x, not with respect to v. So that's why there is addition term, dv over d. Okay, let's do the next problem. find the derivative of x. Alright, so first of all, you express it in the form in the stand form, right? So looks at power function. So by the channel, then dv or dx. So what is a derivative 1 minus v to negative 2, right? So you use another channel here. So what they do is it's negative 2, 1 minus v to negative 2. Then you have to differentiate 1 minus v with respect to v. So that is going to be negative 1. So combine them together. It's 2. Yeah. So this is this is a good example. So sometimes you even don't need to mention the intermediate variable. So it's up to you. After you practice enough, then you probably can skip that part. You don't need to really mention the intermediate variable.